Hai, Assalamualaikum warahmatullahi wabarakatuh. Okay, class. So today we meet again on this video. So we will focus on same topic, fixed effect transistors, but different biasing circuits configuration. Okay. Uh, for this video, okay, we will focus on voltage divider, okay, bias configuration. Alright, okay, I open the slide now. Okay, without further delay, I open the slide now. So as you can see, the circuits arrangement, okay, as you can see in the slide, the circuit arrangement for JFET actually same as BJT. Okay, they have a R1 and R2 at the left side, and then also they have a RD, okay, for the drain, RS, okay, at the source, and then they have a 3 capacitor C1, C2 and C3. Okay, so the main thing is you have to know the arrangement of the circuits is same as BJT. Okay, but the difference is the step of DC analysis. Okay, so we will do a different way, okay, compare with the BJT. Alright, okay, right now to proceed on DC analysis, okay, I remind you, you have to know the basic, okay, condition of JFET. That the rule is you have to know, and then we have discussed in the previous video actually, okay, the current IG, okay, the current at the gate, okay, is equal to 0. So when we apply to this voltage divider circuits, okay, as you can see, okay, when we apply the IG, okay, the current through the gates equal to 0 means, okay, I open to the next slide. Oh, sorry. Move to the next slide. Okay, sorry for the technical problem. Okay, alright. So this what happened on the circuits when we apply IG equal to 0, when we assuming IG equal to 0, okay, so means no current here, so we can open the circuits here, then we can analyze different part, okay, by this side, and then we can find the VG, okay, by using voltage divider rule, and then the current through the R1 and R2 is same, okay, means I R1 equal to I R2, and okay, and then VG here at this nodes, at this point, we can use voltage divider rule to find VG. Okay, alright. Okay, next okay, this one is a voltage divider rule, and then we can assuming that ID equal to IDSS, and then we can find VGS, okay, by using KVL. Okay, so our VGS equal to VG minus IDRS, and then by using a graphical approach, okay, first we have to plot the characteristic curve. Okay, this blue line is characteristic curve by using a shorthand method. Remember the table, okay, when IDSS and BP value are given, so we can plot this blue line, and then we have find these 2 points, okay. The first one is a VG. The first one is actually equal to, by using this equation, okay, when ID equal to 0 M, and then our VGS equal to VG, so we got this point. Okay, so this first point actually equal to VG. Okay, and then the second point, okay, when we apply VGS equal to 0 volt here, and then by using this formula equation, ID equal to VG over RS. Okay, so this VG we just find by using voltage divider rule, and then we already know the value of RS, so we can find the value of ID here. Okay, so we can plot the the second point here. After we plot the first and second point, okay, we just draw the straight line, okay, from the first, second point and third point, and then we can find the intersection point, okay, between the blue and the black line. Okay. Okay, so that's by this intersection point we can find the BGS and ID value. Okay, this is the idea how to do the DC analysis for voltage divider. Okay, for the next slide is okay, I already mentioned actually the IR1 and IR2 is the same, and then we can find by using this formula, and then by applying the second loop, okay, KVL for the second loop, okay, the same thing as you remember in the previous video, we derive the equation to find VDS by using a second loop. Okay, we applying KVL, okay, for the second loop, so that we can find the equation for VDS, BDS and BS as well. Okay. Okay, class, everything clear? Okay, so I will show you, okay, one example. Okay, open the whiteboard first. Okay, alright, this one. Okay, so for example, you are given original circuits for voltage divider, bias configuration for JFET. Okay, alright, and then what you need to do is, okay, what you need to do is to apply the rule. Okay, what is rule? As we know that our IG equal to 0 amp. Okay, when our IG equal to 0 amp, so we can we can cut this line. Okay, so our circuits will be separate circuits for R1 and R2. Okay, R2. So this is our VG. Okay, for DC analysis, okay, we replace all the capacitor with open circuit, so means we ignore all the capacitor for DC analysis. And then for VG, we just use voltage divider rule. Okay, so R2 over R1 plus R2 times BD. Okay, settle. Alright. Okay, what the next step? Okay, you can refer to the slide. Okay. Okay, for the next step, we can draw again. Okay, this is our VDD. Okay, okay, we can draw again. This is our BJT. Okay, RS, RD, R1, R2. Okay. So you can apply to this loop. Okay. So this one we have voltage minus VGS. Okay. This is our IS. Okay. And then we already know, okay, this is our VG, right? Okay, VG. Okay, so we have KVL here. So you can move here if you want. Okay, so our KVL at loop 1, okay, equal to, okay, minus VG plus here plus VGS. Okay, this one plus IS RS equal to 0. Okay. Okay, because we applying, okay, IS equal to ID, so we can replace with ID. Okay, so our BGS equal to, okay, our BGS equal to VG minus ID RS. Okay. Alright, so settle the first part. Okay, now we know the value for VG and VGS. Okay, we know the value, this one, okay, VG, and then the second one is VGS. Okay. Alright, the next thing, okay, I remove here, I move here. Okay. Okay, so next step, okay, next step, okay, this is our next step. Okay, we have to draw the transfer characteristics curve. Okay, we have to draw the transfer characteristic curve by using this table, okay, this shorthand method. Okay, so we find, for example, we find this all for 4 point. So let's say like here, this is ID, and then this is VGS. So we can got this one, okay, curve, okay, this curve. Okay. Okay. Okay, next is Okay, follow this graph. Okay, we find this point, first point and second point and the intersection point. Okay, alright, for the first point, okay, we use this one. Okay, ID equal to 0 milliamp. Okay, this one 0 milliamp, and BGS equal to BG. Okay, BG we already know the value. Okay, by using this one. Okay, this one. Okay, voltage divider rule. Okay, we know the value of the VG. Alright. Okay, next we use this formula. Okay, ID when VGS equal to 0, and then ID equal to VG, okay, over RS. Okay, ID equal to VG over RS. So we find this ID value, and then we can plot the second point. Okay, and then after that, okay, we draw this straight line. Okay, the black one. Okay, then we find this intersection. Okay, so this one is our ID. Okay, this one is our VGS. Okay, actually is the IDQ and VGSQ. Alright. Okay, so what we have now is, okay, first we found the VG, second we found the BGS, right? VGS. Okay, third one we find the IDQ and VGSQ. Okay. Okay, next. Okay, next, by using the same circuits, okay, so we can draw again here. Okay, VDD, RD, RS, this one positive, VDS. Okay, so we can use this loop, second loop, okay, to find VDS. KVL at loop 2. So we have what? This one we have ID, this one also ID. Okay, so positive, negative, don't forget the polarity. Okay, RS ID minus VDS minus ID RD plus VDD equal to 0. So our VDS equal to VDD minus ID. So this one we can combine, and then RS plus RD. Okay, so settle this part. Alright, and the next we can find VD. Okay, we can find VD here. Okay, so we can find VD, we can apply a loop at VD. So this one I can remove. Okay, so positive minus VD. So we can use this one, loop 3. So KVL at loop 3 equal to minus ID RS minus VDS plus VD equal to 0. So VD equal to VDS plus IDRS. Okay, settle. And then we can calculate VS. Okay, VS is here. Okay, so this one is our VS, positive negative, equal to IS RS. So this one we can replace with ID. So VS equal to ID RS. Okay, settle. Alright, settle for voltage divider wise. Okay, so the first thing is you have to remember the how to find the ID and BGSQ, okay, by using this transfer characteristic curve. Okay, for voltage divider, okay, by using this kind of approach, okay, by for example for self bias, okay, different line we have to plot, and also fixed bias. All right, so I think this video until this now. Okay, so we continue next. Okay, actually we have finished and complete for the three type of circuits bias configuration: fixed bias, set bias, and voltage divider bias configuration for JFETs. Okay, for next video, okay, uh, we will discuss on MOSFET. Alright, so thank you for watching. Okay, until we meet again. Okay, alright. Okay, don't forget to do example. Okay, you can refer on our slide. Okay, example 6. Okay, example 6. Put all the value and find the BGSQ, IDQ, BDS, BS, BG, and BD. Okay, so thank you. For those who not subscribe my YouTube channel yet, please subscribe. So hopefully you not miss my video. So we meet again. Alright, so thank you. Bye.